All right, this second video is for all of you Mulan fans out there, the original Disney one. Not going to get into the new one. Reflections, okay? And the effective clause on paper, because I'm reusing this paper because, perfectly good paper, may as well use it, save the trees or whatever. And I guess we don't really need that. So let's talk about what do reflections look like for these function transformations. So just like before, we're going to kind of show this interactively, right? And we've already talked a little bit about what this is going to look like. Right? We talked about it with quadratics. If I have a quadratic function and it opens up, just y equals x squared. But if I have a quadratic function and it opens down, that's negative x squared. And the question becomes, does adding a negative in the front on the outside vertical change, inside horizontal change, theme of this section. If I add a negative to the outside of any function, is it always going to flip upside down? Well, let's look. Let's look about what is the square root of function? Square root of function. If I add a negative on the outside, does this flip? Oh, yep. Definitely flips right upside down. All right, let's look at another one. I look at we haven't done a cubed root function. Remember that cubed root is the same as x to the 1/3. Those are the same things. Is this going to flip upside down? Yes. Depending on who you are, you might say, Jason, this is not flipping upside down. This is flipping left to right. Well, it's sort of doing both. We'll talk about why that is later. Okay. Or we could look at the reciprocal squared function. This guy, put a negative out in the front of the whole thing, and it just flips upside down like so. That's going to be our first transformation of this video. So go back to your old table. It's hopefully not that old by now. And we're going to make a new entry in this table. Okay. So if I want a reflection about the x-axis, and sometimes I will call this a vertical reflection because it flips upside down. That's going to be a negative on the outside of the function. So something like y equals negative x squared. All right. Sorry, I'm trying to decide whether I wanted to fix my lighting or not. Now I'm trying to decide whether I want to fix my webcam or not. So again, outside means a vertical change. Inside means a horizontal change. So again, there's sort of a big implication here, right? What if I have a negative on the inside of the function? All right, well, let's look at this negative on the inside of the function. Well, let's not start with this one. There's a good thing to be said about that one. But let's not start with that one. If I had a negative on the inside of this square root function, it's going to be right there. Okay, negative on the inside. And look what happened. It did just flip left to right. It got reflected about the y-axis. Okay, upside down is about the x-axis. Left to right, it's on the inside. And it reflects the other way. Okay? By the way, if I haven't mentioned it, this is the website desmos.com. It's a great tool for graph assistance. If you ever want to see what a graph looks like, go to Desmos. Good place. All right. So again, if we want a reflection about the y-axis, that's going to be left to right. Horizontal change means on the inside. That's going to be something like, trying to use one I haven't used before. Y equals negative x cubed. Notice outside and inside are very similar, but inside means we need parentheses. Okay. All right, those are the two reflections we're going to talk about. And now we have 4 example problems to kind of look at and use these things. We're on example number 7. And it says, find a formula for the following graph. Okay. And I'm going to give you a graph like so. This is part A, by the way. And it's going to look like this. And it's going to look like this. So first off, we have to identify what is our toolkit function here and pretend that I drew the graph a little bit better. Again, it's a little hard to do things when I have my microphone literally blocking my vision. Okay, what is this shape? It looks a lot like the reciprocal squared function. Okay, right? The reciprocal squared function is 1 over x squared. That looks like this. Well, what I've written down looks very similar, just upside down. So identify our toolkit. It's going to be y equals 1 over x squared, the reciprocal squared function. And we know it's upside down. Or you might say, if you want to be really good, reflected about that x-axis. All right, this is the x-axis. It was up here, but it got reflected down there. So according to our table, it's a vertical change. It has to do with the outside of the function. And reflection means just a negative in front. So it's going to be negative 1 over x squared. Okay, just like so. And we can check our answers. Desmos is great. And again, those poor little scratch marks. Desmos is great for this. Is negative 1 over x squared what this looks like? We check. Add a negative to the front. Ah, yeah, that is roughly what I drew. It's supposed to be the same. All right. Another one. Part B. Let's look at something like this. First off, we have to identify the toolkit, and then what transformations are getting applied to this. So it looks kind of like maybe you don't know. And go back. 3.2. Say, which one of these does that look like? Which one of these? Which one of these does it look like? That looks like this, but it got flipped around. So our toolkit function is going to be the square root of x down here. Okay, so it's going to be square root of x, but what's happening, right? Because square root of x, I don't know, it looks like this. What's happening to this thing? Well, it got flipped upside down and flipped left to right as well, right? Upside down, going to look like this, and then it got flipped left to right as well. There's sort of two things that happened here. All right, it got reflected about both axes. All right, so upside down is a negative on the outside. And then after it got flipped upside down, it also got flipped left to right. Horizontal change, that's going to be a negative on the inside. There's actually got a negative in both places. This is our answer. And don't get grumpy with me when you see this answer. There's two things you might say. One, oh, don't the negatives cancel out? No, they do not cancel out, right? Because the one on the inside is stuck there. It can't come outside. You might say the second thing. You might say, Jason, if we have a negative inside the square root, that's not a real number. You'd be correct. But just because there's a negative x doesn't mean the inside is negative. For example, right? If x is negative 2, what is y? And you might go on negative overload here. If x is negative 2, y is going to be negative square root of negative 2. All right, and these two negatives cancel. You get y is negative root 2. And okay, so this is still a real number. So even though it looks like the inside's negative and it looks like this won't be real, as long as x is negative, the negatives will cancel. And that's why this function is only defined for negative or zero numbers. Okay, something to watch out for here. Next up, part C is going to be number 44 from the book. Let's look at that one. All right. We have to identify the shape. Oh, this one might have reflection, and we also know it has got shifted because there's nothing at 0, 0. You have to find the toolkit function and potentially multiple things. Okay, so first off, identify the toolkit function. Again, kind of like that wavy thing. What does the wavy thing look like? It's kind of like this, but it's waving the wrong way. This is waving to the side. It should be going up and down. Not that, not that. Ah, there it is. Cubic function. Okay, so that's our toolkit function here. The toolkit function for C is y equals x cubed. That's the first step. Now we also have to figure out what is happening to this. Okay. Wait a minute. It's going the wrong way. Normally it's supposed to go up on the right. This one's going down on the right. It's upside down. Okay. We have to say, okay, reflected upside down, reflected about the x-axis. Okay, what is that going to look like? Upside down, that's a negative on the outside. But that's not all that's happening. That's just our first step. Okay, so let's see what else is happening. All right. This is the wrong scene. Here we go. It got shifted over 2 and up 1. Right 2 and up 1. This is sort of the middle of the function if you want to think about it that way. Normally it's at 0. It got shifted right 2 and up 1. That's what we include next. All right, so right 2 and up 1. How do we incorporate that? Right, that's horizontal change. It's going to be on the inside of that cubic function. We write parentheses. Right 2 is going to be minus 2. And then up 1 is going to be a plus 1 at the end. As a side note, the order in which we write these really does matter. We'll talk about the order more later, okay, in video 4. Just watch out for it in the meantime. And again, one way that you can check your answer, well, if you're at home, you can use Desmos. If you're taking a quiz, which would also probably be at home, you can just check by plugging in some numbers, right? This is a function right here. Plug in some numbers and make sure that those numbers that you plug in are on this graph. So for example, this graph has the point 2, 1 on the graph. So if x is 2, we should get 1 out as the y value, and we will. Okay. So let's do one more before we move on. Me not having enough paper. All right. We're going to do the next one vocally. I'm not going to take a break and get some paper. The last one we're going to talk about is 46. All right. So for number 46, what do we have? It kind of looks like an absolute value function, but again, it's upside down. Okay, that's a reflection about the x-axis. Upside down reflects it about this axis. That's going to be negative on the outside. We're also moving it right 2 and up 3. You'd use the same procedures to do this as before. All right? That's all for this video. All right? Enjoy these problems, because video 3 will be a little bit of a reprieve, and video 4 is going to be really fun. All right.